Hello and welcome back to TensorFlow. So today we are going to understand a very important topic of probability, which is conditional probability. So before understanding the conditional probability, let's first understand some basic terminologies used in probability. So the first is events. So what are events? Events can be anything that we are calculating probability of. Some common events in probability are like flipping a coin. So coin toss, flipping a coin is a event, and rolling a die. These are some common events that we talk about in probability. So rolling of dice is another event. So these are the events. Anything we are calculating the probability of, anything that is happening is called event. So the second terminology is sample space. So what are sample space? Basically sample space are all the possible outcome of a given event. So let me give you a clear example. So let's say we want to know the sample space of flipping a coin. So this is the event, and we want to know the sample space of this event. So the sample space is all the possible outcomes of a given event. So the possible outcome of a given event, flipping coin, can be either it will be head or it will be tails. So this is the sample space. This is the sample space of flipping a coin. Let's take another example of rolling a dice. So what will be the sample space of rolling a dice? If we are rolling a dice, fair dice, so it will give us a number between 1 to 6. So 1, 2, 3, 4, 5 and 6. So this will be the sample space of this event, rolling a dice. So sample space. So sample space is all the possible outcomes that can occur while performing the event. So this is the definition of sample space. Now let's understand what are variables and what are random variables. So variable is like x. It can take any value, any value from minus infinity to plus infinity. So variable, the definition of variable is this. Now what is random variable? So random variable is x can take any value between minus infinity to plus infinity. So this is called random variable. Now random variable can be of two types. First is discrete random variable and second is continuous random variable. So in probability there are two types of random variable. First is discrete. So discrete random variable is like rolling a dice. So if we are rolling a dice, we can get 1, 2, 3, 4, 5 or 6. So we can get any number between 1 to 6, but these numbers are discrete, which means we cannot get 1.2 while rolling a dice. We cannot get 1.5 while rolling a dice. Either it will be 1 or it will be 2. There is no such thing as 1.2 or anything in between these two numbers. So this is called discrete random variable. Discrete random variable. Now let's talk about continuous random variable. So continuous random variable will be continuous random variable. So it will be continuous, like one after one it can be 1.01, can be 1.2, it can be 1.5, like this. So these are called continuous random variable. So what will be the example of continuous random variable in terms of probability? So let's say we are calculating the probability of, let's say we have a data of height of people. So height can be of 1 feet, 2 feet, 3 feet, but height can also be of 1.1 feet, 1.2 feet, 1.3 feet. So this data is continuous. So this is called continuous random variable. So these are some basic terminologies that we have to know before understanding conditional probability. So now let's understand these three kind of probabilities: joint probability, marginal probability, and conditional probability. So we have a graph here. So with the help of the graph, we will understand joint, marginal, and conditional probability. So if you'll see, this is the table. We have a table of probabilities, and by this table, we will try to understand the definition of joint, marginal, and conditional probability. So joint probability. Joint probability is probability of two or more events. Let's say, let's understand this table first. So here we have students in a class. So student can be male or female. So this is the graph for students, male and female. Now they will choose subject. So subject can be English or maths. So now we have to calculate the probabilities given this data. So the probability of English student, probability of students who chose English as the subject is this. Probability of a student who chose mathematics is this. Probability of a male student in the class is this. Probability of female students in the class is this. So now joint probability is like we are asking the question, probability of a student, find the probability of students who are male and took English as a subject. So we are asking two questions at a time. First is probability of male students and probability of male students who took English as a subject. So this is called joint probability. In joint probability, we calculate probability of two events at the same time. Now, second is marginal probability. So marginal probability is defined by itself. We calculate the probability of margins, which is this. So we are calculating the single value probability or single event probability. So let's say we are asking for the probability of male in a class, so it is marginal probability. Let's say we ask probability of a student who took English as a subject, so it is marginal probability because we are asking single questions. Here you can see we are asking single questions. So probability of English, probability of female, probability of male, and probability of maths. So these are single probabilities that we are asking questions about. So this is called marginal probability. Now let's come to the main topic, which is conditional probability. So conditional probability is a special kind of probability where we are trying to find the probability of event A given that event B has already occurred. So let's understand it with an example. So let's say we have 52 cards. So in deck of card we have 52 cards, and we draw a random card from these 52 cards. So we are drawing a random card from these 52 cards. So what is the probability that the drawn card is red? So it will be 1 by 52. So this is the probability of finding the red card in these 52 cards. Now let's say we ask another question. What is the probability of finding a red card, given that we have already drawn a card which is red? So now we have restricted the sample space. Now we only have 51 cards in deck because we have already took out one card which is red. So now we have 1 by 51. So this changes the outcome of this changes the probability of finding the red card. So this is called conditional probability, in which we try to find the probability of A given that B has already occurred. So it is written like this, and read like given that. So this is given that sign. So this is the note here. So we reduce our sample space to only those cases where B has happened. So we can understand it with a Venn diagram. So let's say this is our sample space, and this is event A, and this is event B. Let me draw it again. So this is event B. So this is event A, and this is event B, and this is the intersection area where A and B are occurring together. So now we are trying to find probability of event A. So probability of event A, given that B has already occurred. So we are trying to find this region. Now let's first see the formula of conditional probability. So how we find the probability of A given B. So probability of A given B is defined as probability of A intersection B divided by probability of B. So we will derive this formula from this Venn diagram. Now we are trying to find the probability of A, which is this area. But we have already know that B has already occurred. So we have to remove this part. This part we have to remove, and we have to consider this part. So we will calculate the probability of A and B, where A and B occurred together. So we will calculate this part first. So P of A intersection B, and we will divide whole B from this part. So we are removing our already happened event. So we are removing this part. So we will find the probability of A. So we will get probability of A given that B has already occurred. So this is how this formula works. So the main essence of conditional probability is it reduces the sample space. As I have shown you in the card example, so we have 52 cards. We are drawing one card at random. So we are drawing one card at random. What is the probability of getting the red card? It is 1 by 52. But if we ask that what is the probability of finding a red card, given that we have already drawn a card from the deck, so it will reduce the size of the sample space. Now we have only 51 cards, so our outcome will change, and the probability will be 1 by 51. So this is the main essence of conditional probability, and this is how the formula is derived of conditional probability. It is very easy. We are calculating the intersection part. So A intersection B, and we are dividing it by the probability of B. So we are taking these two events, and this is the intersection part. So this is event A, this is event B. We are trying to find the probability of A only. So we have to remove this B. So we are dividing it by B, and we will only get the probability of A here. So this is how we derive the formula, and this is the clear and core essence of conditional probability. So we will use this concept of conditional probability to understand Bayes theorem. So the main objective of this video is to get the prerequisite of Bayes theorem. So Bayes theorem is one of the most important theorem in machine learning, probability, deep learning. It is used in many more fields. So this is the most important theorem in the field of probability and statistics, which is Bayes theorem. And this conditional probability is like a prerequisite for this Bayes theorem. So we will understand this Bayes theorem very clearly in next video.